Welcome to EPG Pathshala's Linguistics course, in particular to its Morphology and Syntax paper for which I am responsible. I am Prabal Das Gupta. I teach at the Indian Statistical Institute in Kolkata. In this particular module, we want to show you what role transformations play in a generative grammar, hence the title, Generative Grammar and Transformations. So in this context, we begin by reminding you that you saw in the preceding module how phrase structure rules and lexical rules formalize the knowledge that we have acquired from traditional grammar and structuralist grammar about syntactic relations between elements in a simple phrase structure tree. We have also seen that formalized in that fashion, a phrase structure grammar cannot find the resources to deal with long distance dependencies, with discontinuous constituents, and with the exchange of selectional requirements between subject and the right-hand side of the sentence in the case of pairs in the active voice and the passive voice, such as Tim admires sincerity and sincerity is admired by Tim. We have also suggested that these drawbacks can be overcome by adding to the machinery of a phrase structure grammar another formal device known as syntactic transformations. We have walked you through the requirements that a syntactic transformation has to fulfill in order to live up to these expectations. In the present module, we will show you exactly how a syntactic transformation goes about its job. Consider the example on which we focused at the end of the last module, the example of a discontinuous constituent. We were looking at the fact that when you want to say something like, John took the garbage out, that is the result of moving the word out to the extreme right edge of the sentence, and you started out with, John took out the garbage. The word out, as you recall, is called a particle. It is a particle which, together with the verb, forms a construction known as the verb particle construction. We have gone into considerable detail in the last exercise of the preceding module so that you are perfectly aware of what the requirements are that the transformation has to live up to. Now let us see how to make a statement that will do this, and how to implement the statement in action. The statement we have to offer what is called the particle movement transformation, which, as the name indicates, moves the particle, has two parts to it. The first part of the statement is called the structural description, abbreviated as SD. The structural description chops up the sentence not from the point of view of what constituents it has, but from the point of view of the place where the transformation will have to intervene, and therefore the landmarks that the transformation needs to see to find that place. This chopping up of the sentence being independent of the branches that you draw in the tree has to be shown differently in the notation. So when we draw the tree for the purposes of doing the transformation, for the purposes of carrying out the instructions given by the transformation, in that version of the tree, we break up the tree into what's called factors. Factors are the paths that the tree seems to have through the eyes of the transformation. The transformation sees the tree differently from the way the phrase structure rules see the tree. The phrase structure rules have created the tree. So there are branches in the tree that were given to it by the phrase structure rules. The branches are crooked lines. They are diagonal. They go like this. For the factorization of the tree, we draw straight lines, and to make sure that the lines are seen as being different, we draw dotted lines. They're interrupted like this, here, 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 here. So a sentence, like the student wrote down the examples, has to be factorized for the purpose of applying the particle movement transformation. We need to find the verb and the particle because the particle has to move out. And because we have to find the verb and the particle, we have to hand wave about what is to the left of the verb and hand wave about what is to the right of the particle. We show the hand waving in the syntactic transformational statement by putting in variables. The relevant variables are here written as x and y. So the structural description on the basis of which we factorize the tree is going to say, find a verb and a particle, and to the left of the verb call everything x, and to the right of the particle call everything y. This gives you 4 factors: x, verb, particle, y. So the structural description is written x dash verb dash particle dash y. Having described the structure, we now intervene to change it. That is the whole point of a transformation. In order to grasp the structure firmly enough for the changing to happen, the structural change line of the transformation, the second line in the statement of the transformation, puts numbers underneath each factor. So where the structural description has x, v, prt, y, the structural change under x writes 1. Under v it writes 2. Under prt for particle it writes 3. Under y it writes 4. You have to match the number exactly with where you've written the factor. There are 4 factors, so there are 4 numbers, 1, 2, 3, 4. After 1, 2, 3, 4, you write a special arrow, a double barreled arrow, not a bidirectional arrow. The arrow points from left to right, only in one direction, but it has 2 lines, not a single line. Why do we have a special arrow? We want to make a distinction between the single shafted arrow with a single line with a V like this, used in phrase structure rules and lexical rules which create the tree, from the double-barreled or double-shafted arrow of this kind, which is used in the notation of a transformation. We want to make a distinction between the notation of a transformation which changes the tree and the notation of phrase structure rules and lexical rules which create the tree. Hence the need for another kind of arrow, otherwise there's nothing fancy about it. So we write 1, 2, 3, 4, double-shafted arrow, 1, 2, 0 instead of 3, because 3 is going to move away from where it is, comma, 4 plus 3. 4 plus 3 says that the third factor has been taken to the right of the fourth factor. Notice that had we written 1, 2, 3, 4 plus 3, we would be giving the instruction, please copy the particle so that it appears twice, once to the right of the verb and once at the extreme right edge of the sentence. Had we given that example, the transformation would not be called particle movement, it would be called particle copying or particle doubling. And the student wrote down the examples would have turned into the student wrote down the examples down. That is not how English works. English does not double the particle. It moves the particle. So the output actually should read, the student wrote the examples down, not the student wrote down the examples down. Therefore, we don't say 1, 2, 3, 4 plus 3. We say 1, 2, 0, 4 plus 3. we put a 0 where the 3 used to be, to show that it vacates its original position to move out. Notice that had we written 1204, 3 would have disappeared completely. The result would be the student wrote the examples. The down would have gone out of the sentence. It would have left completely. That is not what happens either. That would be particle deletion. We are not deleting the particle. We are also not doubling the particle. We are moving it. Moving requires 2 operations. You copy the particle so that there are now 2 copies, one at the extreme right, one in the original position. And then in the original position, you delete the particle. So these 2 other transformations we were talking to you about, which don't exist in English, particle copying and particle deletion, actually they are built into what actually does exist, the particle movement transformation. You should think of movement as being 2 operations taking part in the same transformation, a copying operation and a deletion operation. There are various ways to say this. Instead of calling it copying, you can call it insertion, where the insertion is based on this instruction about what to insert. You're inserting a copy at the extreme right. Whichever terminology one is going to use, depending on one's preference, one ends up describing a transformation as being composed of more than one elementary operation. There are elementary operations of deletion, insertion, substitution, and so on. Remember that we use this kind of terminology also to talk about repair strategies in morphology and phonology. This is not the only context in which terms like this have to be used. So to come back, a transformation is not always one operation. Sometimes it is. But sometimes it is more than one operation carried out together at the same time. In this case, you do have more than one operation. You have an insertion and a deletion. An insertion at the extreme right and the deletion at factor number 3. In representation 2, in diagram 2, we have shown dotted double lines in order to indicate the factorization of the tree. Thus you find that there are dotted lines on both sides of the verb wrote. There are dotted lines on both sides of the material to the left of the verb, the student, which corresponds to the factor x. There are dotted lines on both sides of the particle down, the third factor. And to the right of the third factor, the fourth factor, bounded by dotted lines, is the examples. The examples corresponds to the fourth factor written as the variable y in the structural description of the transformation. On the basis of that factorization, the transformation now goes about its business of changing the tree. What does it do? It removes the third factor, P03, from the position where you find it, and it places it to the right of the fourth factor, which is shown as y. At this stage, we have a problem. The problem is we have not been told exactly what the branches of the tree are going to look like after we are finished. Why? We have not been told exactly where to place the particle down when we are given this instruction 4 plus 3. Surely the particle down does not become a daughter of the mother NP. That would involve drawing a tree where the right hand NP consists of the and then examples and then the particle down. You don't want to imagine that the examples down is a noun phrase. Why don't you want to do this? Because the examples down is not a noun phrase. You cannot say the examples down are really difficult. The examples down bother me a lot. These things are not possible. You cannot say these things. Clearly, you have to put the particle down somewhere else, not as a daughter of NP. What are your choices? You don't really have much of a choice. You end up placing it under the S, because at least the S cannot complain. It has to cover everything. So we make this a convention. If a transformation's instructions have not told you where to put a moved item, make it a daughter of the S. So the particle becomes a daughter of the S. We don't mean that the word down becomes a daughter of the S. Down becomes a daughter of PRT. Remember that the PRT is moving. The transformation was not instructed to move the word down. It was instructed to move PRT. So it has moved PRT with its daughter down attached. The question concerns where to attach PRT above the word PRT. And the answer is PRT becomes a daughter of S. So now that part of your tree is going to say S dominates VP, S dominates PRT. That is the result of adding a convention to the way we're going to do our transformational operations. The convention is if the place where something is going to land has not been specified in the statement of the transformation itself, your default is to attach it to the S as one of the daughters of S. That default applies now. We then give you an exercise concerning sentences like 3 men who look really belligerent just arrived, and 3 men just arrived who look really belligerent. Whereas you can see who look really belligerent is a clause which was originally attached to 3 men and that moves to the right edge of the sentence. This kind of movement is called extraposition. We say that the clause has been extraposed. So we give you this exercise about how to make sure that extraposition applies as a transformation, how to draw it. We are asking you to draw the tree for sentence 4, which is what it looks like after extraposition is applied. The main point we're making is we need to make sure that you've understood the convention of how to place a moving element when the transformation has not given you specific instructions about its landing site, about the place where it lands. That is the point of the exercise. Since we've already told you the convention, surely you will not have trouble understanding. In some places, the transformation tells you where to place something. The transformation specifies the landing site. When that happens, you don't have to apply the convention. And the thing you're talking about does not become a daughter of S by default. When you do passivization, for example, creating a passive sentence out of its active counterpart, turning Tim admires sincerity into sincerity is admired by Tim, you will have to specify the landing site of the moved object so that sincerity takes the place of Tim. Tim moves out, leaving the subject position empty, and then sincerity moves in, so that you get sincerity is admired by Tim. In passivization, the landing site of the moving object is specified, so the convention doesn't have to apply. But the right-hand side of passivization cannot tell you where to place by and where to place the NP Tim. Therefore, the by becomes a daughter of the S, and the noun phrase Tim becomes a daughter of the S by applying the convention. So passivization gives you examples of both of the procedures. One part of the procedure is, if the transformation tells you where to place a moving object, put it where it tells you to. Obey the transformation's instructions. If the transformation does not tell you where to place something, make it a daughter of S. We have told you that adding syntactic transformations to the toolkit of phrase structure rules and lexical rules turns the grammar from a phrase structure grammar into a transformational grammar, And we have told you that as a result, the transformational grammar becomes capable of generating all and only the sentences of a language, and thus becomes not merely a transformational grammar, but a transformational generative grammar, a TG grammar. We are now in a position to say more exactly what is involved in a transformational grammar attaining this type of generative capacity. And we can place it in the context of the rest of what you know about other branches of linguistics. At one level, transformational grammar takes you out of the theoretical architecture of structuralism, which worked with phonemes and morphemes. At another level, transformational grammar is the next step on the structuralist journey, in the sense that it extends the logic of structuralism to the analysis of the sentence. What is the logic of structuralism? The logic of structuralism is that a phoneme is seen as a bunch of allophones in different environments expressing their unity as a phoneme. A morpheme is a bunch of allomorphs in different environments expressing their unity as a morpheme. What keeps a morpheme together is its interface with meaning. One morpheme has exactly one meaning, which is spread out over all these allomorphs having different forms expressing that meaning. A phoneme gets its unity by making a specific and definite contribution to the makeup of an allomorph which expresses a morpheme. So indirectly, a phoneme takes part in encoding meaning. Not that a phoneme itself carries meaning, but phonemes together work as an allomorph representing a morpheme which carries meaning. Therefore, ultimately, a phoneme is making a contribution to the enterprise of expressing meaning. So the phoneme is the point at which the allophones into which the phoneme is spread out take part in the enterprise of expressing meaning. When you take this logic to the analysis of the sentence, you want to talk about the sentence-eme and allosentences by the same logic of something-emes and allo-somethings. Phoneme and allophone, morpheme and allomorph, sentence-eme and allosentence. By the same logic, a sentence-eme expresses a shared, unified meaning, and the allosentences are different forms which all express exactly the same meaning, but differ at the formal level. This is what we are able to implement if we have syntactic transformations. I'll give you an actual example. Consider the 4 allosentences. Everybody hates the man who threw the pearl away. The man who threw the pearl away is hated by everybody. The man is hated by everybody who threw the pearl away. The man is hated by everybody who threw away the pearl. These 4 sentences are all allosentences of the same sentence-eme because they express the same meaning. How do they differ? Transformational grammar tells you exactly how they differ. They are derived from the same sentence-eme. If you apply particle shift to the sentence-eme, you get everybody hates the man who threw the pearl away. Away has been shifted to the right. If you apply passivization to the sentence-eme, you get the man who threw away the pearl is hated by everybody. If you apply both passivization and particle shift to the sentence-eme, you get the man who threw the pearl away is hated by everybody. If you apply passivization and extraposition to the sentence-eme, you get the man is hated by everybody who threw away the pearl. If you apply all 3 transformations to the sentence-eme, you get the man is hated by everybody who threw the pearl away. So transformational grammar allows you to unpack how all these allosentences are related to the same sentence seam. It is each allosentence is derived from the sentence seam by applying one or more syntactic transformations. So far, I have been using this informal pair of words, sentence seam and allosentence, in order to bring out the architectural similarity between the concepts of transformational grammar with the predecessor framework, structuralism, which worked in terms of phonemes and morphemes. In fact, no practicing transformational grammarian has ever used the term sentence seam or ever used the term allosentence. Where we have been saying sentence seam for the last few minutes, in fact, the term actually used is deep structure. Where we have been using the term allosentence for the last few minutes, in fact, the official term used by transformational grammarians is surface structures. So there are distinct surface structures that are derived from a shared deep structure by applying one or more syntactic transformations. That is the picture that we're integrating into the architecture by using the non-standard terms allosentence for surface structure and sentence seam for deep structure. Thereby, we're emphasizing the fact that the sentence eam, being the eam, is the point which encounters the meaning. Indeed, in the architecture of classical transformational grammar, which we are teaching you in this course, the deep structure is that part of the derivation which alone is accountable for the meaning of the sentence. Transformations are not allowed to touch the meaning. All the surface structures derived from the same deep structure carry the same meaning. That is what makes them surface structures sharing the same deep structure. Another aspect of a grammar being not only transformational but generative is the fact that it is responsible for generating all and only the sentences of the entire language. And it's important to understand that you cannot specify the number of sentences in a language. The reason that we cannot specify how many sentences there are in a language is that there is no number to provide. The number of sentences in a language is infinite. Since the number of sentences in a language is infinite, the task of a transformational generative grammar is to generate that infinite set and to do so efficiently and optimally. Exactly what makes the number of sentences infinite? The answer to that question lies in recursion. There are certain rules in the system of generative syntax which are recursive rules. For example, a rule introducing coordinate clauses that takes S on the left-hand side and then after the arrow writes S conjunction S, responsible for John is sad and Mary is happy, for example. Such a rule, such a phrase structure rule, S arrow S conjunction S, allows you to generate not only S mother daughters S conjunction S, but to reapply to this S and have S daughter S conjunction S, reapply to that S, have S daughter S conjunction S. So you've got grandmother S and 2 S daughters and 4 S granddaughters, and then you can multiply as much as you want, and you can get a conjunction with infinitely many sentences coordinated. That is one example of recursive rule. There are other forms of recursion in human languages where it is not a single rule that performs the recursion, but a combination of two rules working together that has a recursive effect. For example, when you take a noun phrase containing a complement clause, the fact that John is boring, the structure of that noun phrase is noun phrase, determiner, noun, sentence. The fact That John is boring. That John is boring is a sentence, fact is a noun, the is a determiner. Det and S determiner noun sentence is the structure of that noun phrase. How did you get the noun phrase in the first place? You got the noun phrase because there's a phrase structure rule saying S goes to NP-VP. Then there's another phrase structure rule saying NP goes to det and S. Now you repeated the S here that you had up there. So at this S, you can again say S goes to NP-VP. Then you can take that NP again and say det and S. So you can say the fact that the difficulty that John is boring, etc., etc. You can make it a multiple complex noun phrase containing a sentence whose noun phrase is again complex. You can do this wherever you like. You can intervene in these ways and make the sentence longer and more complicated. Because the phrase structure system has direct recursion like S on the left and the right of the same arrow, or S goes to NP, VP, and NP goes to det and S, where the S is responsible for a second S after the application of two rules. These two rules form a recursive complex, if you wish. That is a case of indirect recursion. Because of indirect recursion and direct recursion, the number of sentences in a language is infinite. And that is something that generative grammar is equipped to handle. It is time to summarize. In this particular module of the course on morphology and syntax, we have tried to show you exactly how a transformation applies to a tree and how a transformation is so stated as to specify the details of this application. We also pointed out to you that there is one kind of detail that transformations in their statements are not well equipped to specify. We refer here to the details of the constituent structure of the output. So we put in place a convention to handle that gap in the system. The convention being that when the landing site of some constituent is not specified, it turns into a daughter of the nearest S. With that convention in place, we walked you through the statement of a transformation called particle movement that takes the particle out of an English verb particle construction and places it to the right of the sentence. We also showed you what happens when the transformation does specify the landing site of a moving constituent, such as the passivization transformation, telling you that the object of the deep structure takes the place of the subject. We then went on to introduce the terms deep structure and surface structure when we explained how transformational grammar, in a certain sense, extends the architectural style of structuralist phonology and morphology to the level of the sentence. As a result of that extension, it becomes the responsibility of the deep structure of the sentence, which we for a while labeled as the sentence EAM, to handle the meaning aspect of the sentence, while the allosentences, called the surface structures in actual transformational parlance, are derived from this deep structure by applying one or more syntactic transformations. We walked you through some examples of this. In the final section of our module, we showed you in what way the recursion property, shown as indirect recursion in certain phrase structure rules and shown as direct recursion in certain recursive phrase structure rules and as indirect recursion, which is an effect of the joint action of more than one phrase structure rule in other cases, gives rise to the fact that the number of sentences in any human language is infinite. This is the connection between recursion and infinity, which makes it necessary to say that a generative grammar has the task of accounting for the properties of an infinite range of sentences in every language. This was what we managed to get done in this module of what is a very exciting subject at the cutting edge of human inquiry, generative syntax. It is in some ways what has been seen as the most exciting branch of linguistics in the last few decades. This is the beginning of your exposure to transformational syntax, the cutting edge of linguistic research. As we go through the next few modules, you'll be getting deeper and deeper into the subject. We should warn you at this stage that the formal details of transformational grammar, although they are important, are not the heart of the matter because the formal details change. You need to understand the architecture in which the various levels of linguistic description are connected to each other by the traffic of these formal devices. Don't get too caught up in the traffic. That is like taking the car more seriously than the passengers. The passengers are supremely important. The car is merely a vehicle. Likewise, when you're learning the nitty-gritty details of transformational syntax, don't get too caught up in the nitty-gritty. At the same time, we are not asking you to ignore the nitty-gritty. Please study the e-text extremely carefully. Make sure you get all the details right. We are merely asking you not to get obsessed by them. Also, please follow up all pointers to further reading that are given in the e-text. And do not hesitate to come to us with any questions or criticisms that you have. Thank you for your attention.